Hi, this is Marcin from Luna, and in this video I'm going to show you how to expand on our trams example to get real-time information about the tram velocities as they are moving through town. So we will be starting pretty much where we left off, except we have a few things prepared. First of all, we have the distance function prepared, which is based on the hover-sign function. It is a standard way of measuring distances on Earth. And we have all the functions that we have created so far, so we know how to download the data and how to format it into something that's actually useful for us. We have also pre-fetched two pieces of data from the API, and that will help us greatly with creating our solution and with testing it on some data first. Let's start by reading the files that we have downloaded before. So we are reading the initial file. We are parsing it as a JSON, as a piece of JSON data. And then we are converting it to a list and running our tram creation function. So the function that can get the ID and the geographical coordinates of each tram. So we can see our data neatly formatted here, and now we will do the same with the second file. So we are pretty much repeating the same flow for the second time here, so that we can work on both files at the same time. And we can immediately see that there is something wrong with our data. Basically, both files have different lengths. So we have 135 elements in the first file and 149 in the second. So the only way around this is to create a lookup table for the trams. So we will be creating a map based on the ID of a tram, and then we will try to match both tables together so that we get some coherent data for further use. So we are using the fold function, and the fold function is a very simple function that takes an initial value and a function to run with each element of the collection. So we will be inserting each element of our trams collection into this newly created lookup table. And now that the lookup table is ready, we can actually use it with our trams. So for each tram, we will look up the relevant information in the second table. And this is done using the lookup function. And now if we look into our data, we can actually see that some values are not available. So we are right all along with the fact that we needed this lookup table because we have some missing values. So this means that in this API, trams can pop in and out of existence without much notice. And we will now filter out all the records that are missing. So we will use our old friend, the filter function, and we will filter all the elements that have the third column present. And now our data seems complete, and we can actually start computing some distances. So what we will be doing now is for each element of this table, we will get the geographical coordinates of the first point, and we will then compute the distance to the second point. And we can see that we have successfully computed some distances, so we are pretty much done with this section. We can now select all the nodes that do not touch reading something from the disk and fold them into a single function. And as you can see, the newly created function returns the same result, so we have some distances. We can also see that some of the trams weren't moving that much. So now we don't need this cache data, and let's actually make this run on some real data. So let's start by doing what we already know how to do. Let's run our getTrams function every 5 seconds, and let's then compute distances. So now we have a stream of values, and we want to run an operation on every pair of consecutive values. So we will be zipping our collection of trams with the same collection but moved by one, which is done using the tail method on the stream object. So now we have our collection of distances ready, and what remains to do is to actually convert those to GeoJSON features so that we can display them neatly on a map, and to compute the velocities, because we have just computed the distances. So to compute velocities, we need to divide it by the time interval that we are using for this API. Also, we will be using a special property in our GeoJSON feature object, which is pop-up content. And the pop-up content feature tells Luna to display whatever is the value of this field as a pop-up when it visualizes the result as a map. So now we can just press enter, and after we're done, we can easily see a map with all the trams moving, as we have already seen before. But now we can click on any each of those and see the current velocity it has. We can also see that some of the records have kind of nonsensical speeds, like 123 kilometers per hour. So we have potentially found a problem with the API. It's probably just some records getting stale. We can also see that some of the trams aren't moving that much. They will probably catch up in later iterations. And we can also see that some of those actually have speeds that are very probable for a tram. So these are probably the trams that are best connected to our API. So thank you for watching, and if you have any questions or remarks that you want to share, please do so. Please let me know about anything.